Hey guys, Joe Pye here at Advanced Innovations. Welcome back to my shop. Today's chore and one of the closing elements in this little cannon build is to finally secure the wheels to the axles. And for everybody that has said where the little bouncing ball is right now, you need to shorten that. Well, it has been shortened and it has been chamfered. Now, what I want to do is, this looks like a tapered pin coming through here, which would probably be period correct. It might be a square wedge, but I don't want to make a square wedge. I'm going to make it round. And in order to make it look like it's tapered, I'm going to go this route with it. It's actually cylindrical, but it's straight. The hole in the top of the collar is going to be bigger than the hole in the bottom of the collar, and when it's installed, that little shoulder right there that you can see entering the part now will pass through the wood, because the wood has the same size hole as the major diameter of the pin, and the bottom hole, well, the shoulder is going to interfere and it's going to stop, and it's going to look like that when it's done. So I think that's a win. Simple feature, but devil's in the details, right? I want it to look like it's tapered, but I don't want to have to go through the hassle of tapering and figuring out how to do the wood and blah, 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 yada, yada. Okay, the other thing we got to do is this little trunnion lock mechanism up here, which has already been machined, but this little pin, originally called out as a flat wedge, slides in and out and locks the trunnion in place. Now, having an eyelet on it like that would be nice, because then you can secure it with a chain, an ornamental chain that just dangles and secures somewhere on the side of the cannon body, which I think would look pretty good. I could stay with this model and detail this until the cows come home, but you got to say enough is enough at some point in time. And no, the trunnion does not go across the barrel, and I know the barrel may be hanging upside down, so please save me from those comments. I'm working from a picture here, guys. Cut me a break. The back, the elevation mechanism on the barrel, will be controlled by a sliding wooden wedge that will be simply formed on a belt sander and stuffed under there to wrap this project up. Yes, I will stain the chassis. The chassis is mahogany. I'm probably going to put a walnut stain on it to darken it up like this. I think I like the way that looks against the brass. It should look great. Let's go out to the mill, sit these little brass rings in a V-block, and drill the cross holes in it. I think you're going to like the V-block setup. If this is one of those parts that not only will there be a V-block lesson, something for you to think about and consider if you're making one or have one, but I think you're going to like the way I hold these things. Let's get out to the mill. Do it. This particular setup is going to be done in a sacrificial V-block. This is a piece of aluminum, and the easiest way to make your own V-block is to just take a slug of material and position it in your primary vise at 45 degrees. Then use the side of the cutter. One side will be cut by the side of the cutter, and the other side will be cut by the bottom of the cutter. It will always be symmetrical at 45 degrees. Now, to double check that, for this particular setup, I'm going to put a pin in here under pressure and trim each side. Now, I did set this up off camera, so this is just strictly a mechanical exercise to show you what I'm doing. Trim this side to 0, come back around, trim this side to 0. If you have any doubt whatsoever of the accuracy of the V-block that you made and you want to double check it, use another size pin right now without moving the table on the x-axis and trim it again. If there's a discrepancy in the indicator, well, then there's probably a discrepancy in the V-notch. As the diameter of the pin changes, the center line will migrate accordingly depending on which way the V is notched in there or which way the block is set in there incorrectly. Right now I know that I am currently set on my x-axis center line. I want to set up for the y-axis. I'm going to do that with the edge finder against the end of the pin. Sometimes it's easier to set the fixture up and put the part in than it is to put the part in the fixture and try to find the part. So we're just going to go on blind faith here. Zero out the pin for the center of the V-block, pick up the back and move in, and then we'll figure out how to put the part in there, since the part is considerably smaller than the block. With the pin clamped in the V-block at the same pressure I plan to hold the part, I'm going to pick up the end of the pin with the edge finder. I get a lot of questions about how fast I run my edge finder. That was running at 1400 RPM, and I did it twice because the first time I hit 0, the first time it kicked out, I zeroed my digital and I went back and double checked it to see that it kicked out in the exact same spot the second time around. As for the part, the reason I'm using a sacrificial V-block is because I plan to drill all the way through it. There's the part. And I'm sure there's a lot of you that know exactly what I'm going to do. This is a pin exactly the same size as the part. There you go. Part's back here. I'm not going to be anywhere near it. Gentle pressure, centered in the V-block, picked up on the Y-axis for the 0 in the rear. Now I can put the step holes through the center. I'm going to put a small 93 thou hole all the way through it, and then the top one's going to be 128, so I can use the step pin for the wheels. Be extremely careful when you're center drilling thin wall material. As the drill breaks through, it's going to want to dive in. Drill the small hole first because this side can act as a guide for the bottom side. Now the easiest way to know that you are through the back side is to drill until cast iron comes up. No, I'm only kidding, don't do that. That would be terrible. But that's a great way to fool somebody if they're ever drilling a hole and they walk away. Take some cast iron chips and throw it on the V-block or whatever. Say, hey, I went too deep with the hill. Oop, oop. All right. No, that's mean. Don't do that. Apprentices need to pay their dues, right? We've all done it. All had it done to us. Here we go. Just top hole and we're done. Doesn't get much easier than that, guys. No sense in boring you with the remainder of the operations. I have 3 more of these to do. I'm going to move over to the lathe to make the step pins and put the wheels on this thing. Now in this particular clip, there is a stop down inside of this collet. I'm going to polish the visible part of that particular raw material that will be visible at assembly, of course. Chamfer everything. This is going to be a finished end that's going to be turned around and fed back into the collet. I am not going to a stop. I am not going to any setting on the digital. All I'm doing right now is cleaning up the end of these parts. If you establish a reference point or a 0 point from a part that's too short and you cut all your other parts to that same length, you might get yourself in trouble. So do the first side by eye. And what you just saw me do there, pressing on a spinning part with a part off tit on it, not advisable. If you know how hard you can press it and you know your fingers are well calloused, well then have at it. But for the most part, guys, turn the machine off before you do that, or you're going to have a series of small holes in your fingers. So that the material doesn't pull into the tool, I take the majority of the material off on the first bite and then take a small finish pass to boot. The next cut is going to be done with a, I need about a 30-degree edge on the tool that I'm running. But I know a 30-degree tool is not going to clear the distance from the end of the part to the face of the collet. So I'm going to do it with a threading tool, but I'm going to bump the tool holder at a certain angle visually by eye, just so that it matches the interior or the internal diameter of those small brass rings. This is that tangent point that I spoke about before. I'm going to visually line it up by eye with the loop and set the height and adjust the diameter, testing it against an actual ring off camera to make sure that it fits. You know, when you count on a drill to drill oversized and it drills right on size like a reamer, only when you don't want it to, right? It is a very sharp tool, so the feed has to be exceptionally slow or the surface finish would be absolutely horrible. Once I've dialed in the tool for the diameter that I'm looking for, I will not move the cross slide. I will put all the remaining parts in the collet, in the setup, and I will cut all the remaining parts with the cross slide set exactly where it was. This is such a light superficial cut that material deflection should not be an issue. In this type of setup, if you can get away with it, it is really nice to be able to hold specific, very specific diameters without pulling your hair out. Don't move anything. Cut one. Make sure that you replicate the load on the tool for the second part in line. If there's any difference, go through a couple of pieces before you figure it out. But there you go. That is the look I've been looking for. That is the look I've been looking for. There you go. Now, if that doesn't look tapered, I don't know. I would see that sitting on a table somewhere, and I would say absolutely tapered. But that inside shoulder, and I did it with a threading tool, an offset threading tool, so there's a slight bevel on it to allow for the radius on the inside of the ring. Might as well just do them all, right? When I drilled the holes in the wood, I spaced it out so I'd have about a 10 or 15 thousandths gap behind the wheel. I think that's a win, guys. I do. Let's see if the pins fall out. Next piece in line is the little tapered wedge that holds the trunnion strap down, and then I don't know if I'm going to call that a day and that'll be the end of this series or not. I guess I got to stick a firecracker down in that barrel and see if it fires right. It is not going to be a black powder cannon. I am not going to put the touch hole in it and go through that. It's just an ornamental, it's a desk piece, and that's the way I wanted to keep it. Let's scan out. Oh, that's scanning in, right? There we go. I like the way that came out. I think this is probably going to be the end of this one. Next one's going to be the assembly and done. Thank you very much for tuning in wherever you are in the world. I hope you're well and happy and safe. Not necessarily in that order, but certainly all three. Me, it is a Friday afternoon, and I'm out of here. So, Joe Pye, Advanced Innovations, Austin, Texas. I'm out.